Hello, Intro to Chemistry students. I wanted to go through, I know we talked last week about converting from mass to moles and moles to mass, and then also from moles to particles and particles to moles. But I wanted to do a couple of examples that show you converting all the way from mass and grams all the way to particles and back and forth, because I realized some of the problems on the worksheet actually had some of those types of problems in. So I just want to do a couple of those in order to help you complete that worksheet. So let's say that I want to know how many molecules of NaCl, which is sodium chloride, are in a 15-gram sample. So remember our conversion factors. We said, so I'm starting with, I have to be clear on my path here. I want to end, or I'm starting with 15 grams and I want to end up with molecules, right? So my path is going to go from grams, which is here, and I want to go to molecules, which is all the way down here. So to get there, I have to go from grams to moles, right? So grams to moles, and that will be one conversion factor, this one right here. And then I need another conversion factor to get from moles to particles. So molecules is one of the category of particles, so molecules. So because I know really quickly looking at this that I need one conversion factor to get from here to here, one conversion factor to get from here to here, so I'm actually going to have two conversion factors. I'm going to show you how to work through that. So I'm going to start with 15 grams. My first conversion factor, right, because I'm following this arrow, is 1 mole is over the molar mass. So 1 mole is going to go on top. And remember, when I look at this, I'm trying to get to moles first, but I want you to do this as one consecutive problem. I need to look up the molar mass. If I look on my periodic table, sodium is 23 and chlorine is 35.45. I'm going to go 35.5. All right, I ran out of space there. So sodium is 23, chlorine is 35.5. So it's going to be something 0.5. Looks like 58.5. Okay, so 58.5. Remember what this means. This is 58.5 grams in 1 mole. Don't forget that. So if I stopped right here, remember also that a whole number is like a fraction over 1. So if I stopped right here, the units of grams would cancel out and I would be left with moles. But I don't want moles, I want molecules. So I have one more step to go. I want to do this as one long continuous problem. The great thing about this conversion factor right here is it's the same regardless of whatever substance I have, because we're using Avogadro's number on top over 1 mole. So here's And I always want to check to make sure that everything is going to cancel out. I want to end up with molecules, so moles cancels out right here. And all that I will be left with is actually molecules, so this actually works perfect. Here are my little tidbits, and I know I said this in the last video. You must make sure that when you're plugging this into your calculator, parentheses. And then I'm going to multiply everything that's on the top. So I'm going to grab my calculator. I like my scientific calculator. So I take 15 times, and then parentheses, 6.02 times 10 to the 23rd. Make sure you know how to use your calculator. If I wanted to, I could write, you do what works for you. I usually don't do this step, but I could solve for the top, which is 9.03. And then my calculator says, my calculator says 9.03 and then E24. That really means 9.03 times 10 to the 24th power. Don't forget that. So I'm going to take this and then everything on the bottom multiplied together. So 58.5 times 1 times 1. And then I need to do this final solve. 1.5. 1.5 times 10 to the 23rd. Again, don't forget, you probably want to put parentheses around this when you're punching it in your calculator if you're doing it this way. So 1.5 times 10 to the 23rd. Does that seem reasonable? Yeah, I mean, if 1 mole of this substance is 58.5, I only have 15 grams, so I have way less than a mole. So this should be way less than 1 mole of particles. 1 mole of particles, remember, is 6.02 times 10 to the 23rd. So yeah, I have way less than that. That seems like a reasonable number. So let's do one more going the other way. So let's solve one going the opposite direction. So I'm going to underline what's important. I want to end up with grams. I want to know how many grams are in a sample of H2O. So I need to know that it's water. And then I have this many molecules. So I know when I set this up, my path is going to be, I'm starting with molecules. So I'm going from here to here. This is going to be 2 conversion factors, right? I'm starting with my 7.5 times 10 to the 23rd molecules. This is my path. Molecules to moles to grams. I'm going molecules to moles to grams. And I just follow this arrow and it tells me what my conversion factors are. So I'm starting with 7.5 times 10 to the 20th. And I do know that I'm going to have 2 conversion factors because I have 1 conversion factor here and another conversion factor here. So my first step is going to be to go from molecules to moles. The conversion factor is 1 mole over, and this 6.02 times 10 to the 23rd, remember this is, in this case, this is molecules, right? So again, remember when we have whole number, it's like a fraction over 1. Molecules totally cancels out. I'm left with moles, but I want to get all the way to grams, so I want to go from moles to grams. I need to find the molar mass of water in order to be able to do that. It's H2O. (18 grams per mole). I want to end up with grams, and I want to get rid of moles. So I want moles to go on the bottom and then grams to go on top. 18 grams. If I set this up right, which I'm pretty sure I did, moles cancels out because they're diagonal from each other. The only thing I'm left with is grams. All right, so now again, I want to put parentheses around this when I enter it in the calculator. Handy dandy calculator. I'm going to enter in 7.5 times 10 to the 20th. Multiply that by 1, and then multiply that by 18. And then I'm going to take that number and divide it by everything on the bottom multiplied together, which is 1 times 6.02 times 10 to the 23rd. How many grams? It's a really small number. And then does that make sense? Well, yeah, because this is a number much smaller than 1 mole, so that makes sense. So there we have it. Like just a couple of quick examples going. The first example, and you can watch this video as many times as you need to. The first example going from grams all the way to molecules, those particles, and the second one going in that opposite direction. Just remember this Avogadro's number. This can mean it's particles, so it could be atoms, it could be molecules, it could be marshmallows, who knows, right? But if you have 6.02 times 10 to the 23rd of anything, you have 1 mole of that substance, and we call that Avogadro's number. It was miraculous in chemistry when we figured that out, that we could take any of those masses from the periodic table, put them in grams, and it would give us 1 mole of that substance, and it was always that many particles of a substance. So good luck. Use this information to finish the worksheet from last week, and please email me with any questions.